Greetings, everyone. We'll get started in just a minute. We're racking up participants as we speak. When it slows down a little bit, I'll launch into today's workshop. Okay, we will get started. Welcome to the California Efficient Yields Workshop on Facility Design and Construction Best Practices. This is the first of a series of 4 workshops for California Efficient Yields. I'm Rob Eddy, the Technical Director for Resource Innovation Institute. On behalf of Carmen Nazaretti, the Engineering Operations Manager, who is the wizard behind the curtain today, we welcome you to this workshop. This is going to be great. I've been really looking forward to this. The way this workshop will work is that I'll facilitate a discussion with our panel of experts. I've identified one of them beforehand to address each of the topics that you see on this agenda, but the others can jump in whenever they wish. So it's going to be an open discussion. The less I talk, the more valuable the workshop will be to you, especially if our panelists talk amongst themselves or answer your questions directly. So that's my goal here. As we go along, you can write questions in the Zoom chat, and if I don't see them, Carmen will let me know at the end of each topic section. You can also press the raise your hand button, and at the end of each section, again, Carmen will let me know that we've got someone who wants to ask a question. All right. Or you can chime in by voice at the end of each section or during the Q&A at the end of the presentation. So we're going to leave at least 10 minutes, if not 15, for questions. All right, allow me to start by telling you who we are putting this on. We're Resource Innovation Institute. We're a data-driven nonprofit organization focused on research and advocacy to improve the resource efficiency of the CEA industry. A little history about us. For its first 4 years, RII served primarily the cannabis industry, providing objective, non-biased information, which was hard to come by in those days. Along with providing information, we provided much needed help with the policy in an industry often described as the Wild West. We also have a mission for bringing our training to underserved communities. In 2020, we received a USDA grant to apply our expertise in climate policy, utility programs, green building certification, et cetera, to the CEA industry, which is the reason we're here today. Our mission is to measure, verify, and celebrate the most efficient agricultural ideas. We develop key performance indicators using data gathered from growers in our PowerScore software. PowerScore is our tool to help our members verify that using the best practices indeed works to reduce emissions while maintaining or improving the canopy productivity of their facilities. So of course, we're interested in both, how their business is doing and also how their resources are being used efficiently. We develop case studies to promote the success of our producers, which enriches the data and in turn helps us to create sound policy recommendations. We're very well connected with all the players in the market: growers, the supply chain, utilities, local government, and academia. We produce and publish best practice guides, then educate based on the content of those guides by providing workshops like this, seminars, roundtables, conferences, and writing articles in trade journals for trade journals for several different industries. We believe bringing all these players to the table can transform the industry into a more resource efficient one, more so than any of us could do alone. So we're real proud of what we do, and we are delighted with the kind of support we get from all those different players in the industry. We form working groups of growers, vendors in the supply chain, and they help us distill their experience into the form of these best practice guides. And the subjects including lighting, controls automation, HVAC, water circularity. This workshop is based on our most recent guide for the CEA construction and design. This Technology Advisory Council helps us shape the scope of these guides, the outline, the terminology, which is for a brand new industry like this is very important. Some of the key issues, challenges, benefits, and really help us describe the technology and the best practices that are brand agnostic. So the members of the TAC take off their company hats and put on their industry community hat, and we're grateful to them for doing that, much like our panelists today are doing. If this sounds like a role you'd kind of like to be a part of, consider becoming an RII member, and you could join one of these groups, and we'd love to have you. Our library of best practices guidance is available in our catalog. This year, we have published the best practice guides for design and construction, as well as for HVAC design, installation and maintenance. In 2023, we'll publish the water circularity best practice guide that I'm working on now with my working group, as well as the CEA controls and automation best practice guide. So, like I said, today I'll be presenting slides that are in that best practice guide to highlight for you and to promote this discussion. But if the discussion gets rolling, like I think it will, don't be surprised if I skip over some of the slides for the sake of time, because you can always read those best practices guides at any time by downloading them from the RII catalog. So let's start off. Let's do some introductions. I'll go first, and then we'll go to Brian, and then Holden and Luis. I'm so proud to be here with the three of them. Again, my name's Rob Eddy. My background is in greenhouse and plant growth facility management. I was at Purdue for 20 years. I was at Dow AgroSciences for 3 years, and I was a private consultant in the cannabis and hydroponic industry for about 5 years before coming to RII. Brian, tell us a little bit about yourself.
Thanks, Rob, and hi, everybody. There's some names on the folks who have dialed in, so that I recognize, so thank you all for joining. I'm an architect. We're headquartered in Cambridge, Massachusetts. I came to the cannabis industry with roughly 20 years as a general practitioner in architecture, but specifically working in clean room environments, medical research laboratories, as well as plenty of retail. So I had a smattering of things that really brought me in 2014 into cannabis. We now have a national practice. We're licensed in 14 states. We nominally have an office in Fullerton, California, mostly on paper. We're headquartered, as I said, in Cambridge, but working throughout the US, both in controlled environment horticulture, manufacturing spaces, primarily, and for the purpose of this call, in the controlled environment space, greenhouses and controlled indoor grows is the bulk of our practice here nationally.
Thank you, Brian. Holden?
Hey, everyone. My name is Holden Orler. I am a senior project manager with Arco Murray. My background was in design. So prior to working for Arco, I was an engineer for a design firm. Came over to Arco, kind of the best of both worlds, got to oversee the design as well as oversee the construction. My first project with Arco was actually a greenhouse. And ever since then, I was sort of hooked on the CEA space. My entire career at Arco has been dedicated to the CEA space. I've worked on a variety of projects, everything from greenhouses for leafy greens, vertical farms, cannabis, indoor grows, retrofits, ground up, as well as cannabis greenhouses. So excited to be here to share some of my lessons learned and experiences.
Great, thank you, Holden. Luis?
Thank you, Rob. Hi, everybody. My name is Luis Trujillo. I'm the president of Holden USA. I've been working with Holden for the last almost 4 years. I've been in the industry for about 9 years now. I'm an IT engineer, been involved in different greenhouse projects, controlled environment agriculture in vertical farms and different types of systems. Holden is one of the top players in the world in controls and environmental controls for this industry, the segment in high tech. And we're here to try to share a little bit of our data-driven growing experience and to learn also from everybody here.
Thank you, Luis. Holden also incorporates the plant empowerment principles into their software, so it's very exciting development. Before we go on, I just want to also thank Southern California Edison, who are sponsoring this workshop, and we'll talk a little bit about some of their programs towards the end. Let's talk about the market in California briefly. As you know, the largest cannabis market is in California with over 6,000 licenses. You can see the breakdown of the kinds of licenses on this chart that Carmen put together for us. It's a $4 billion legal market and with an estimated $8 billion illicit market. Is that right, Carmen? Do I have that right?
Yeah, I believe so.
Yeah, I think it was 8. Just remarkable the size of the market. So also beyond cannabis, California has a massive CEA landscape, number one in most of the areas. So most area dedicated to CEA, the largest tomato growing, largest berry, largest vegetable growing area, and this is under protection. These stats aren't for the field. These are under protection, which means, if nothing else, at least a hoop house with some active controls. Second largest mushroom growing area in the country. So mushrooms, the more I learn about it, the more amazed I am about the size of that market. This chart kind of gives you a visual feel for just how big and important California is. In floriculture, which is flowering crops, it's second only to Florida. It has the largest nursery stock crop area and the second largest cut flower area. Purpose of today's workshop is to encourage cultivators to participate in SCE and California efficiency programs. Also to convey scientific insights and industry expertise. That's what we'll be introducing as we get into our technical discussion, bringing this directly to the producers and to find the best ways to translate them in the context of their local ecosystem. And also, we're going to help energy efficiency programs achieve their savings goals through education and knowledge sharing. So those are some of our goals. The learning doesn't stop with this webinar. You can also visit the virtual classroom where you can see the recording of this webinar, see tip clips, downloadable resources, and also more information on SCE and PG&E's state program tools. So there's the account for resourceinnovation.org California. Create an account there to see that virtual classroom. And you can register for upcoming workshops. Again, this is just number 1 out of 4. We are really pumped about this program. Next one will be lighting best practices. That's coming up on October 18th. Then optimizing CEA environments by aligning your HVAC systems with your SOPs, November 8th, and then controls and automation practices for efficient greenhouses and indoor agriculture in December. So sign up for those, and it's just going to keep getting better. So we're going to start off our discussion now. First, we're going to talk about some of the benefits of controlled environment agriculture. I'll jump into a few of those, and then I'm going to open it up to our panelists. So I've got 3 slides here on some scientific insights. Then we'll open it up. I'll probably ask Holden to get us started once I get through with these. So some of the benefits are pretty obvious, and some of them you may not think about unless someone points them out. So obviously, more crop cycles per year than growing in the field. You can manipulate the photo period, or the amount of the length of light period for off-season cropping. So you can make make plants flower or stay vegetative according to the day length if they respond to that. Not all plants do. And you can do that using light deprivation curtains, or also called blackout curtains. And also you can do it with lighting techniques. You have a good chance of producing a more consistent crop because you can keep a more consistent environment with CEA, obviously. You can improve the scheduling for market timing I'll just give an example of flowers, flower production. For Mother's Day, that is the big day. That is like Thanksgiving to them. That's when they make their margin. So they've got to be able to schedule their crops to be flowering, ready, and in the market by Mother's Day. Same thing with Valentine's Day. So that's just one example. And of course, there's making perpetual harvest allows you to, cannabis, for example, where you have this routine harvesting going on throughout the year, so you can keep your product in the distribution center. You can come up with environmental recipes using CA. You can optimize to each crop specific needs. CA also provides that opportunity, which is what we're so excited about, to be more resource efficient. You can recapture the water you use for irrigation and reuse it. You can recapture the HVAC condensate and use that. You can use shade curtains and thermal curtains to save energy. You can use your environment system to steer your crop to more productivity so that you get more harvested material per unit of energy spent. And you also can manipulate the environment and the scheduling your crop to avoid peak loads. Okay, a big issue, good way to save a lot of money on your energy bill. And also, CEA allows the use of CO2 enrichment. Let's talk about that for a minute. So CO2 is used in photosynthesis. Plants use water that they take up from the roots, and they use CO2 that they bring in from the air through the pores on the bottom of their leaves. And they split those molecules, the water they split, the CO2 they split, and they put those C's and H's together in O's to make carbohydrates, which are the building blocks for everything they're going to make, DNA, cell walls, everything that they do. Okay, so in order for this to take place at a reasonable rate, you need to have at least 400 parts per million CO2, because that's about what the atmosphere is. Of course, it's increasing all the time. It's up near 430 now, I believe, 430 parts per million. The thing to remember that, though, is that if you have a really nicely built, tightly sealed greenhouse or grow room, which is what your goal is, plants can suck down that CO2 level below 400. So they're not even experiencing what they would outdoors. And so you might need CO2 enrichment technology just to keep you above 400. Of course, you can also use elevated CO2 to increase yield by increasing photosynthesis. When you do that, light and temperature also have to be elevated. Just a note of caution, you can't just increase yield by increasing CO2. If you really want to do it, you want to try to keep them all elevated, right? However, there's another nice trick that I want you to know about. CO2 can be used with low light and cool temperatures to maintain the normal photosynthetic rate while saving energy. So in some ways, CO2 can replace light. It can replace heating that you're providing. So it just that you're not going to get elevated levels, but you're going to get the normal levels of yield while keeping your energy bills down. So if you have CO2 enrichment, it gives you a lot of choices. You can elevate to try to improve yield, or if you're at a period in the market where things you're really hurting and you just need to save money, you can use it to keep your yields normal while saving energy. But of course, in a greenhouse, another caution is that if you've got a greenhouse with passive ventilation, you're opening up vents, you don't want to be pumping into CO2 into that environment and just letting it go out the vents. So but you can still have it, because often though you can time this with a good control system. You can have CO2 enrichment in the morning and the evenings when you don't have to open up the vents, because it's normally not, so you don't need that kind of ventilation in those periods, and still get increased plant growth just by controlling it in those periods. For a long time, we just controlled growing areas with temperature and with relative humidity. Okay, now relative humidity, we were using that for disease control, because we just knew if water condenses on the leaves, that's a ticket for powdery mildew and disaster, right? There's nothing wrong with that. We still need relative humidity, but what we want to use relative humidity now is to control the vapor pressure deficit. And the reason we want to do VPD control rather than relative humidity control is that VPD allows you to optimize photosynthesis and growth. Okay, so what is VPD? Bear with me here. It's not scary. This is really easy. It's technically a difference in vapor pressure between the plant's stomata, those little pores in the bottom of the leaf, and the atmosphere around the plant. Okay, and water vapor pressure is just how many water molecules are squeezed into the air. So So you have a high vapor pressure in that little pore, that leaf, and you almost, well, typically you'll have a lower vapor pressure out in the air, and so that drives this movement of water out of the plant into the air. And while it's being driven out of the plant through the stomata, more is being sucked up from the root. Okay, if it helps to give this concept human characteristics, think of it as how thirsty the air surrounding the plant is. Okay, so that's why I got this cute little picture of a straw. The environment sucks water out of the soil, the root substrate, using the plant like you would use a straw. Okay, and if you don't have enough suction to draw much water out of that straw, then the plant is not going to thrive. And if the suction is too high and you drain all the water in the bottom of the glass, then the plant's going to be in trouble because it's going to go into water stress. So you want to keep that amount of suction at about 0.8 to 1.1 kilopascals. It varies between species, okay, but that's a good recommendation. So this chart here is really cool because it shows you what I mean by how you can use environmental controls to manipulate VPD. You can, if you follow this chart, the vertical axis goes from lower temperature to higher temperatures as you go up, and the horizontal axis goes from low humidity to high humidity as you go from right to left. And the VPD I've circled is if you go from 74 degrees and 65%, and you see that's a VPD of 1, which is this yellow band is the optimum band, right? This is for cannabis, by the way. But you could also see the same VPD up at 84 degrees and 75% humidity. So the plant would be equally happy, equally transpiring and bringing up water and nutrients at those two different regimes. And so if you wanted to save money in your cooling, you could grow your plants warmer as long as you could increase the humidity. All right, hope that wasn't too scary. Make sure I got this. So that's a little bit about the scientific insights. Now I want to talk to our panel. Holden, why don't you tell us about additional considerations about the benefits of controlled environments, whether it be a good greenhouse, tightly controlled greenhouse, or an indoor room, benefits of one or the other, if you have any opinions, and what might get overlooked. You'll start us off and we'll let the rest of the panel join in.
Yeah, so I think, I guess I'll preface this by saying I think it depends on the grower, the operator, and what they're trying to achieve. But to answer the question directly about, some of the benefits of indoor farms over greenhouses, I do think that with, fully indoor cultivation, your ability to control the environmental parameters are a little bit simpler, because you're not dealing with some of the outside influences of the climate around you, whether it's the temperature, the light cycle changing throughout the course of the year. If you're growing a flowering plant and you have, more than 12 hours, then you need some sort of light deprivation. All of those things can be addressed through greenhouses, through a control system, as I'm sure Luis can speak to in a little more detail. But certainly from a simplicity standpoint, you have a lot more control in a fully indoor environment. Along with that, you kind of touched on sort of a lot of these greenhouses are vented. So from a biosecurity standpoint, I think a fully indoor cultivation does have an advantage in that regard. And then also odor as well. If you're specifically for cannabis, if you're trying to grow cannabis in, especially in an urban setting, it can be challenging if you have a vented greenhouse to control those odors from the neighbors around you. I think another thing too for a lot of our clients is the repeatability and scalability of it. So for an indoor grow, it's pretty easy to take the same program in Southern California, take that program and recreate it in Michigan or on the East Coast or Florida, because it's not influenced by the climate around it as much. Your mechanical systems will be impacted a little bit. They'll be derated, but by and large, you can take the same program and repeat it all over the country. So that's appealing to some of our clients who are looking to operate in multiple states across the country. Whereas a greenhouse, your optimum greenhouse solution in Southern California versus Denver versus Chicago is probably going to look a little bit different. So from a repeatability and scalability standpoint, there's definitely some benefits to indoor cultivations in that regard.
That's great. How about Brian or Luis? Is there anything else you'd like to add for benefits or challenges of CEA production?
Luis, go ahead.
Well, what I would say is a little bit what you were stating, Rob, on the CO2. That's becoming a big challenge. There is shortage of CO2. So what you have, you might use it very efficiently, and in an indoor, you will have that possibility. And in a greenhouse also, but you're a little bit more, let's say, under the circumstances of the external weather, and you have to, those influences, you have to take them in account. So you're limited. In an fully indoor, you're not limited. So you can really make a very, very efficient CO2 strategy, I would say. And that helps a lot. And nowadays, even more because of what we're experiencing, let's say, in the industry.
I'll add one of the major factors that we see in operations now is automation. So labor is incredibly expensive. It is certainly possible with controlled, with completely, sealed environments, warehouse type grows, to manage automation, but the regularity and the systemization of greenhouse grows absolutely lends itself to automation. If you're looking to raise a crop in an area where the labor pool is low and you still want to be profitable, there are Dutch style mobile benching. It is possible in sort of warehouse environments, fully controlled environments. As Holden was saying, there's a lot of controls that are available. But when you balance that with automation, larger open spaces that the greenhouses afford can also be an advantage. And we find that the labor costs often drive post construction labor costs, the next biggest piece in horticulture.
Oh, thank you, Brian. Great points. Before I go on to the next section, Carmen, do we have any questions in the chat or anyone who's raised their hand that we should address?
Yeah, I believe there's one about leaf surface temperature as a metric for VPD.
Oh, excellent. Does anyone want to talk about I think the question is, should you use air temperature versus leaf temperature when calculating VPD? Does anyone want to talk about that?
I can give a little bit of insight. What we use going in that direction also to calculate that VPD is a infrared camera or a thermal view camera to have that VPD using the leaf temperature. Yeah.
Very cool. Anything else, Carmen?
No, just that whenever you change the slides, we can all see it.
Okay, excellent. So next we'll talk about assembling CEA project teams. I'm going to talk a minute about this, and probably going to start with Holden again. So this is just a nice diagram from our best practices guide that gives estimates. Every project is going to be different, but estimates of how long each of these phases take from going from planning to construction to operation, but also very importantly, especially to new people doing their first construction, which things need to take place simultaneously. When do you start permitting, getting your permits? When do you start your procurement of equipment? So this is a very simple but effective way to talk about how you're going to proceed with your project. Holden, you got a lot of experience with building teams. Can you give us some insights on this, on your experience?
Yeah, absolutely. I think I love the slide you have up here, Rob. I think that, on the front end, one of the most important things is that planning and pre-design process, particularly for some of these larger facilities. What we're seeing a lot of times is the utilities can actually end up being the critical path for your project. So if, when you're going through site selection or building selection, if you don't spend a lot of time and establish a solid upfront team to understand, what your general utility requirements will be, even prior to going through the full design phase, to kind of vet through different sites and different buildings, you can actually end up saving yourself a lot of time on the back end if you select a site only to find out that the utility company is going to take 2 to 3 years to bring you the power you need to operate your facility. So I think establishing a strong pre-construction team on the front end before you ever even go to look at sites or buildings is really important. The other thing I would add is that, your design team is going to be comprised of a lot of your traditional designers, whether it's your architects, your structural, your MEPs, if you're doing a site development, your civil. Alongside of those designers, as much as possible, if you can get some of the, I'll call it CEA specific vendors engaged earlier on, it's going to help to make your design process more seamless. So folks like the controls vendor, the automation vendors, the security vendors, lighting vendors, racking and benching, having those folks involved on the front end is going to make the design process go much smoother. Because in the absence of that, I think that your architect and your MEP designers have to make some level of assumptions until those vendors are selected. And then you have to go back and validate those assumptions as those vendors get selected. So if you don't know exactly what type of light you're going to use or what type of bench you're going to use, you can't perform an egress study until you know the width of your benches and how much they're going to move. So engaging those folks earlier on is going to help to make that design process go much smoother and avoid the cost and time associated with redesign. And then the last thing I'll say, obviously I'm a little biased being a design builder, but I think having a general contractor or a design builder, someone who can give you feedback on your project budget as you're developing your design, will help to avoid the value engineering process that I oftentimes sees if those checks aren't done along the way, where you get a full set of drawings, but it's over budget. So then you have to spend, 8 to 10 weeks going back and redesigning that. So having someone on board your design team to provide sort of budget checks at the 25%, 50%, 75% set, so that, the owner or the client can it helps inform some of those design decisions rather than making them in a vacuum.
I back that up 100%, Holden. As an architect working in this space, two vital pieces you've mentioned there is systems integration, right? We call this horticulture process engineering, to have someone who can help in the process. If we do manufacturing in other industries, there is always a process engineer involved in looking at systems that are not primary systems, mechanical, electrical, plumbing, and fire protection, right? What happens to is there a solvent involved? Is there ethanol? Is there CO2 involved? All of these in horticulture, there are many, many, many sub processes that have to be integrated into the system. So I 100% concur with that. Bring whether it's a vendor or whether it's an actual designer who can design it, product as agnostic, is sometimes important, and you don't get wrapped around the axle. But in the absence of a true designer, having a vendor on board can save a huge amount of time. And second piece, I fully concur. A builder on board early saves a massive amount of time. There's absolutely zero sense in waiting on this chart right here below on this slide. Having the both working simultaneously is the best option.
Great. Tell me a bit about the sort of specialized consultants that you may have had to use for any of your projects.
I definitely can take that one. As an architect in this space, I'm out early with customers at site selection. I present to planning boards to try to get projects permitted within local municipalities, so municipal entitlements, municipal approvals. And those are the big, those are security. Town usually wants to know, is it secure? If it's a lettuce facility in the suburbs, not so much, right? Or in pure agricultural, but as it moves into regulated areas, security consultants huge. Acoustic engineers we worked with when the systems are when there's pretty intense systems. So if the project has total controlled environment, where you're working with chilled water as a primary system, The noise of running a facility 24/7 can have a high impact. So working with acoustic engineers early to mitigate and mollify sort of, community pressure is important. Odor management fits in that same category. I know folks all over California converting from cut flowers into cannabis have had massive, neighborhood pushback over these issues. So odor mitigation is much less scientific than acoustical engineering. There's really good data and precedent in what drives sound pressure. There's not a lot of measurable data when it comes to odor. It doesn't have the same kind of unit of measurement. Sniff test is much harder to, does it offend you or does it appeal to you? Is much harder to control for. Others, absolutely, as I mentioned, whether if you're producing a product, if you're growing a product that's going to be processed on site, then there are a number of process engineers that need to be, Luis, and what controls do. Controls engineers are massively important early in the process. Chemical engineers we work with, controls engineers we work with early. Fire protection engineers, if you're doing a vertical grow, the NFPA has a lot to say about how fire protection works. Whether you're, do you have plastic trays in racks, and are those above 8 feet? There's an NFPA section for that, and you've got to worry about how water flows down through those racks. So I could go on and on.
Yeah, thank you. That's great. Any questions about building CEA teams, putting together a good team from the folks listening in? I know we've got a couple of questions about costs and such. We'll come back to those in the end if we can't answer them in the chat.
Rob, I would say that in that list nowadays also you can add an energy consultant there, because it's you do get some very, very specific energy programs, rebates, and those type of things per state or per that can represent an important amount of money even. Thank you, Luis, because that one of the points of this program, this workshop, is to remind people of that.
It's the energy consultants for the rebates on the front end, but also someone who can help to help you through energy procurement. Because I think, if you have someone that's able to navigate the energy market, that's one of the easiest ways to reduce your operating costs without changing anything, is to work with someone who can make sure that you're getting the best rate possible on the energy market as well.
And, shout out to our sponsors as well. I know PG&E and Southern California Electric all have specialized consultants on their teams, liaisons on their teams, to help the farmer understand, is the power that you need available at the site you're selecting. So call your energy, figure out who's the provider. Is it gas? Is it electric? Is it water? Figure out who your provider is for those utilities and contact them early. That is a fundamental.
Great. We're going to jump to our next subject, the value of commissioning and monitoring. Okay. So I've got a few slides here based on an article that you can find in November 2020, Cannabis Business Times, called "Reduce Expenses by Commissioning Your Cannabis Facility." So I'll go through these. And then sorry, say again. All right. So I'll go through these 3 slides and we'll open it up again. One of the vital points is you could save energy, 3% and 12% for industrial facilities by focusing on this. A little bit about some of the things you may not think about with commissioning is not just testing if the equipment works, but performing the sequence of operations testing, because usually heating and cooling and sometimes lighting and shade curtains, they will have sequences where they are in phases, and you want to make sure those are happening at the right time. Also, another challenge might be is if you're using a really sophisticated lighting control system, third party, you're going to have a lot more integration. So your commissioning of that is going to involve that integrated startup, that networking of the interface and interactive GUI. So that's going to take a little bit more time and a little bit more specific expertise. probably provided you by your light vendor than if you were just having lights that were on timers. And of course, you need to validate you're actually reaching your target ranges of whatever it might be, in this case, VPD or temperature and such, but not just reaching them, but are you also, are you logging? And is that logging being done at the right frequency for you to be able to use that information to optimize your growth? And do you have enough storage space for all that data? Because you will, I promise you, you'll want to go back 5 years and see a 5-year trend for certain things. So you can see how different, especially if you're in a greenhouse, I should say, because each year is going to be a little bit different. And so, again, let's bring it out to the panel. Brian, I'll start again. I'll start with you. Can you talk to me about a tiered model approach for commissioning? Could you explain that to us?
Sure. So a tiered model. Well, actually, let me preface that with a statement to help put commissioning into context, maybe for some listeners who haven't really ever commissioned a facility before. But sophisticated systems need to be commissioned to make sure that they work properly. And there are multiple checks and balances between the architect, the engineers do checks and balances, the constructor, the installer do checks and balances. Vendors who install equipment do their own commissioning. So it's important that, but from a business, for folks out there who are in the business or starting businesses, the mantra is really say what you're going to do what you said you're going to do, and then document what you did. And if you don't write it down, if you don't document what you say you're going to do, it's very hard to commission anything, right? So the idea about commissioning is we have to have a good set of documents to say, what is it that you set out to do? The way I would tier that, and the best way I can explain to folks, is that there are many, many systems going on, right? There's an envelope. The greenhouse could be your envelope, it could be a converted warehouse as your envelope. So there is building commissioning. We can commission the performance of the building. The second are your primary systems, MEP and FP systems, your mechanical heating, and how do you control the environment of the primary function of that building. And the third is your equipment, and equipment can be commissioned or must be commissioned. So I would look at commissioning as a tiered approach, because ideally you would have, let's say, 3 commissioners, each one being responsible for your primary systems, one being responsible for your building and your envelope, and one being responsible for the pieces of equipment that are designed to function for your process, and have those report up to a prime commissioner and commissioning agent who can interface with ownership, interface with the design team. So that's what I would be my approach to it.
Excellent. Thank you, Brian. Any comments from Holden or Luis on that before we move on?
Nope.
No, I think it's so important in these facilities, in the startup of these facilities. I think, a lot of times it seems like, okay, the horticulture control system is going to be commissioned, the BAS system is going to be commissioned, so it's all covered. The boiler is going to be commissioned, but having someone to take responsibility for the integration and scheduling and documentation of all of these different commissioning activities that go on a project is absolutely critical. A lot of times they need to happen in a certain order. So just letting people, different vendors come out at different times to do their commissioning, it's not going to be an efficient process. So
that's right.
Having someone oversee that is so important, in these facilities. And also functional testing, making sure in a lot of these facilities, you are phasing into it. So it might be 10 months before flower room 25 ever sees any load. So, for us on the GC side, our workmanship and warranty period with our vendors and subcontractors, equipment is longer, but for workmanship, it might be 12 months. So we want to identify any of those issues as we're turning over the facility not 10 months later when the facility is operational and we have to send techs in there to fix things. We want to go through and check every point. We want to do functional testing on every piece of equipment, identify those issues, and get everything resolved on the front end rather than having to come back later.
Yeah.
We've got a question from one of our viewers because it relates to having a special consultant, particularly for energy procurement. The question is, can you negotiate kilowatt hour costs with the power provider? Specifically, they're asking about Southern California or the rates that are set.
It depends on the utility.
Yeah.
I'm not sure about Southern California specifically, but some are on an open market where it can be purchased. You can hedge it. There's certain strategies that you can take. And then there are other utilities that are not on an open market.
Very good.
And being so this goes back to your efficiency and some of the things that come through controls and some of the way you set up this call. It's important to negotiate with the utility provider over cost and about cost, because the things that controlled environment growing allows the grower to do could be to defer peak load to an off-peak time. And that would be something critically important to the utility provider. And, that's the piece that needs to be negotiated. That level of detail is what you need to bring to the table, to the negotiating table. If you have the opportunity to shift your peak load or to make moves like that, that's going to be of absolute interest, because these are large energy consuming projects.
Yeah. There's Rob, there's two things there. There's also ways of thinking and for these projects to do cogeneration or CHPs, or be completely, let's say, autonomous on the energy side and even become a provider of the network. It will all depend on the numbers, on the financials and cost, capex and opex. And there sometimes it's a good deal to go that direction, sometimes not. That's why the energy consultants are key in the process to make that review and, let's say, financial plan. And that we see that quite a bit now in greenhouses, now in indoor facilities. I think that's going to come, and also could be also adding our component of renewable energy sometimes, but that's another story, I'd say. Yeah.
Thank you. We've got a question in the chat that I think will hold to the end. David Flores, fantastic question about photoperiodism and how that might be used to save energy, manipulating photoperiodism. I do need to jump on to the next section, which is navigating codes and permits. I'm going to talk a little bit about the Title 24 very briefly, okay? And this is in a building with CEH spaces with more than 40 kilowatts of aggregate horticulture lighting load. The electrical lighting systems used for plant growth and light and plant maintenance shall meet the following requirements. So now we're beginning to see California saying this is how efficient your lights need to be. This is how efficient your time switch lighting controls need to be. And they also have specific guidelines for multi-level lighting controls. So the lighting is being regulated now, what kind you can use. The greenhouse envelope is being regulated more tightly with this. And the one I would point out here is the non-opaque roof assemblies must have a combined U factor of 0.7 or less. So we'll get to a chart a little later in this presentation that will show you that kind of keeps you from using single pane glass, among other things. So very, very specific outcomes from these regulations. And also humidification is now, dehumidification is being looked at and regulated for its minimum integrated energy factor, which is how many liters that you are dehumidifying per kilowatt hour. So all of these things are now in Title 24, and I encourage you to take a closer look at that. There's, in addition to Title 24, of course, there are a myriad of codes that have to be kept track of. I want to start off, maybe I'll start off with Brian again, then go to Holden. Brian, can you share experience and advice on code and permit adherence?
Wow. Yeah, this could turn into a long night, but
Yeah, don't really answer all of them,
I'll keep it brief.
yeah.
I mentioned a little bit about fire code in vertical farming. That's a hot button. I know fire marshals and assistant fire marshals all across the country are studying Class A plastics above 8 feet. So if you're considering multi-tiered racking, you've got to pay close attention to the type of materials used in the rack, the height of the rack, the clearance to the ceiling above the rack, sprinkler heads, etc. So fire protection is huge, and that's NFPA. The overlooked part of NFPA that I've run into really interesting in a project in Michigan is in rural areas, building greenhouses. There's been confusion as to what type of building that is. It's really important to understand use type. So traditionally, you go a real quick read of the building code tells you that a greenhouse is a utility building, type U. But in fact, closed environment greenhouses are not. They're actually type F1, factory moderate hazard. And as a result, they need to be sprinkled over 7,500, anything over 7,500 square feet. If you're in a rural community with no water in the street, no water pipes, no fire hydrants in the street leading up to your property, you may have to build a fire tower, a reservoir, with hundreds of thousands of gallons of water for the fire company to plug into if something happens. So fire code is a huge piece that gets overlooked because traditionally, we just considered hoop houses and greenhouses to be utility buildings. But the more sophisticated they get, you may switch from a U type to an F type.
Yeah.
So that's a big one.
I don't want to make you have to go through all these, of course. Holden, how about this? Holden, do you have any stories you can tell us of things that have gone right or something very clever that someone did to make sure they complied with the code?
Yeah, I similar to Brian, we could have a whole separate discussion on this one slide, but just to kind of build on some of the things he was saying, fire protection is a huge one in vertical farms as well as in greenhouses. Not only, another sort of ambiguous thing that we ran into is how do you treat the shades within a greenhouse? Is that an obstruction? Because the NFPA wants your sprinkler pipes up at the peaks. So if those shades are closed, does that fall under an obstruction within NFPA? From a greenhouse standpoint, a lot of the greenhouses are designed using design software from the Netherlands, and that software, while they are inputting the inputs for that specific location, doesn't always directly translate to building codes here in the United States. So it's important to have, going back to, when you're assembling your project team, it's always beneficial to have a structural engineer that understands that software, the structural calculations that if your greenhouse is coming from the Netherlands, the calculations there, and can convert them to US building codes to present that to a building code official and show them, hey, this is adequate under US building codes, especially important in seismic regions such as California. And the last thing I would add is UL listing is another big one. In the CEA space, a lot of the equipment is coming from overseas, whether it's Europe or Canada or Asia. And if that equipment doesn't carry a UL certification, it can and a lot of times will be flagged by an inspector as not being UL certified. And so that will need to go through a whole third-party on-site inspection, which takes a significant amount of time and costs a lot of money. So if you are sourcing equipment from overseas, it's very important to check to make sure that it carries that UL certification.
Ah, fantastic. Thank you, Holden. We'll jump to our next subject. Make sure we keep on pace here. Design and construction best practices. This is just a great chart. Brian, do you have a half a minute or a minute to tell us a little bit about this chart?
I know this chart well. I produced it, so sure. What there are, it's systems integration. I guess this chart is what I'm trying to get at in this is that there are multiple systems of integration. We've been hitting on these topics all along. You know, what I think one of the most important pieces that I would highlight here is energy consumption and performance. Ultimately, the performance of a controlled environment facility today is many of the pieces are well known, right? The equipment is well known. There are port specific HVAC/D manufacturers out there. I think that the real play here has gotten down to a very narrow piece, which Luis represents, which is control systems. And that the better as control systems are in a facility, the higher performance is going to be. If you can measure the water temperature, the root temperature, we talked about leaf temperature, the atmospheric temperature, and that's in that sort of data collection piece. You see the little Internet of Things there. Yeah. Symbol. If you can tie that properly into rooftop solar or your renewable systems and your building management BMS systems, that is what's going to lead to, I think, the most efficiencies and the highest gains today as we begin to assemble expert teams in terms of building these tight facilities, expert teams in terms of the engineering that goes into them. The next sort of new frontier I see is data collection.
Excellent. Luis, can you build on that about the best practices for environmental monitoring and data collection?
I think so. Brian did a very good explanation. I would just add, as Brian and Holden have mentioned already a little bit in the past, is the integration of those systems. That's the key. Those dots where you see those lines and dots, that integration is key. Sometimes we're talking about some protocols, BACnet, Modbus, and type of integration, that to see how those systems are going to talk between themselves and what's the purpose of talking, because that's the main point. It's what are we going to do? We're going to use the data collection to define a growing strategy, and we need the BMS to follow certain levels of CO2, temperature, humidity. So we need to be able to talk between those systems to make it work. Basically, I would just add that as a first thought. And well, AI, yeah, you mentioned AI, and Rob, you said something very interesting, is historical data. The AI can only really be efficient and work if it has a good amount of information, a reliable information that can be used to learn, because actually the system has to learn from the information generated, and that's going to give the possibility of setting up an AI system, an autonomous system, if we could call it like that. And that's the next step, because the system is going to be able to predict what's going to happen, and based on those predictions, it's going to take decisions. And those decisions are going to be, like, for example, if we use 15% less energy, we're going to produce 3% less. If we make the numbers, maybe nowadays with the cost of the energy, that's going to be a good deal for everybody, and depending on the market, demand and supply. So those are the factors that AI will give an incredible, powerful tool to make this a profitable business at the end.
Oh, wonderful point. I want the audience to know that we're not going to talk about all these design considerations. You can read our best practices guide to get more details. I'm just going to read them off while I'm doing that. After I read them off, Holden, tell me which one of these, just give me an example or a story of something that's been overlooked, and kind of let people know what the consequences of not considering all this. So, of course, the design considerations would include the envelope, the wall construction, and how well sealed they are, and how food safe they are. Can they be cleaned? Flexibility of spaces, cleanability, floor drains. You know, sometimes I don't see floor drains in facilities, and I just kind of wonder how much time is going to be spent with squeegee. Cascading airflow, equipment qualification. We've talked a little bit about UL listing. Ability to scale up and expand that facility, designing that in the beginning, and equipment system and redundancy. Holden, you got any comments about this and some that might be overlooked? Or
Within these bullet points specifically, Rob?
No, within anything.
Okay. I think wall construction, it's like, 8 years ago before cannabis was, I'd say more designers had experience with it. We saw facilities using drywall for wall construction.
Hmm.
You do not want anything in that room that could potentially mold. So, that's the first thing that, I would look at on this list. Floor drainage is extremely important. Not only, if you are going to have trench drains, I think trench drains are great in grow rooms because they do provide, a larger area to direct water to. But if you are going to have trench drains, I've seen in some facilities, you need to have a cleaning practice for that. So you need to be able to pop up the trench drain covers and actually clean them and do that on a regular basis. Otherwise, there is potential for contamination within that. Ability to scale up and expand. I think when you're selecting your HVAC system, this is a big one. If you are going to go to more of a central plant approach where you have, a centralized chiller and a centralized boiler, like a 4-pipe HVAC system, it gets a little bit more complicated to build a building room by room. If your goal is to kind of expand, once a year, I want to build four more grow rooms here, four more. It's harder to just add on those blocks with a centralized system because you have to go through and recommission the whole system, and there's, it can impact other rooms within that. And if you are going to do that, you need to have, that central equipment, your piping, everything needs to be sized with that in mind. Whereas if you're going to go more of a packaged HVAC approach, each of the rooms sort of operate independently. So it's a little bit easier for expansion.
Oh, wonderful. Thank you. How about, go ahead, Brian, please.
I was going to add, just to remind people, that was an indoor grow, that photograph you had up, which is great. And if you're doing an indoor grow, just remember that a box has 6 sides. So wall construction is super important, but don't forget about the ceiling. I've seen different approaches to this across the country where folks just bring those four walls up and maybe use the building as the ceiling. Don't do it. Resist, don't do it. It is not a place to save money. Build a complete environment that is like this one, a nice epoxy floor, insulated metal panel walls, but give it an insulated metal panel ceiling as well. Don't let the building structure serve as your ceiling.
Yeah, you can get condensation within the roof insulation. And if you're in a cold environment, freeze thaw, you'll get billowing in your roofing material. So couldn't agree more, Brian.
So like a box within a box.
That's right.
How about, again, we could talk for hours on construction. Is there any underlying principles that you would tell folks to avoid trouble with construction? Timing each step to avoid conflict, considering environmental conditions, the testing. We've covered a lot of this. Is there anything else, Brian? Maybe you could start. Anything else that we haven't covered in our other sections?
Construction is going to go smooth and clean if they're involved early, if there's good synergy between your team, right? That's just paramount. Proper planning, prevents poor performance for all the hockey players out there, right? It's just the only way to get these things to run well is to properly plan them. So right now, Holden could probably talk logistics and supply chain. So procurement is what's driving the industry from my experience, whether it's electrical switchgear.
Let's talk about that. Go ahead.
All right. Holden, I'll let you take it, but we're designing facilities to meet a procurement schedule typically. So good evidence of why you want the builder on board early. If your switchgear has a 60-week lead time, then that is the most important piece in figuring out your total lighting load so that the engineer can get a one-line diagram and you can start talking to Pacific Gas Electric or Southern California Edison and tell them actually how much power you're going to need so that we can design the switchgear and get a drop. That's the first most important piece of the job.
Great.
Yeah, I couldn't agree more. I mean, I think, nowadays, in some way, shape, or form, procurement is falling on our critical path, probably 9 out of 10 projects. 4 years ago, that was not the case. It's, items you have up on here, structural steel, roofing along with that is an extremely long lead time. If you're doing precast or tilt, extremely long lead time. Gear is a really big one. And to Brian's point, I think because there is such a push for speed to market, whether it's in the cannabis space or the food space, you're competing for shelf space in grocery stores in different regions. You know, as a design builder, we're constantly looking for ways to release that long lead equipment when it's appropriate. So, you know, you don't necessarily need to be 100% designed in order to know, hey, I need a 4,000 amp switch gear with this many breakers. But you also don't want to do it too early because, you know, there may be some evolution in design that could change those breaker sizes. So there's kind of depending on where you are in the design process, we see more and more folks releasing equipment earlier at some degree of risk, because the alternative is the completion date of the project could push 6 months to a year.
Yeah. Luis, how about computer components for the things that you build? Are you still suffering from long lead times?
It is, I think so, a global problem, and everybody is suffering a little bit of some more than others. But yes, I think it's a problem. We, as a company, have, let's say, taken a little bit care of that and have plans to stock ourselves, not to have too long lead times, but it is, let's say, it could become a challenge depending on which type of equipment. For the moment, it's as your lead time there, it's between, we're still trying to keep those 12 weeks, making an effort, but yeah, it can become a challenge at any moment, because it will depend on say all the global industry, and there's a big peak now, and not so many provision of equipment, and so it could become a tougher problem. We see it, let's say, as a problem, but for us it's under control. Luckily, it's under control.
Great. I'm going to move on to talking about special considerations for greenhouses, because we've spent some time with indoors, and just make sure we cover this as well for our listeners. So one thing I want to point out is there's some great data that's available from the weather services, which will help you make some decisions about a greenhouse and where you're choosing to locate it and what that might infer about the equipment you'll be using. On the left is an average relative humidity map of the United States. This will tell you where you're probably going to have to dehumidify and where you might have to humidify. And on the right is the daily light integral map by month. And daily light integral is the same thing as a light sum or a light accumulation, meaning how many moles per day of light you get. It's kind of like a rain gauge, as opposed to when you're measuring PAR with a meter that tells you intensity, but DLI is like how much accumulates, like a rain gauge. And these cool maps that came out of Clemson will tell you month by month where you are, how much natural light you're getting. On top of that, for a greenhouse, you're going to be losing, I promise you, you're going to be losing a lot of light through not just through the glazing, whatever that might be, glass or polycarbonate, but all the other infrastructure up there. So count on losing maybe 30 or 40%. I've seen it almost 50% of the light from the outdoors just before it even gets to your plants. And this then tells, when you start doing those calculations, you start looking at December and you say, wow, I'm not going to even get enough light to keep my plants flowering. That tells you that you're going to need some supplemental light, and about how much more you're going to need, because there are targets for DLI for crops published now. For lettuce, you need 17. For cannabis, you need, well, it'd be nice to have 40 moles per day. For tomatoes, around 30. So you can start to do the math using these weather data maps. Luis, I'll come back to you. Are there any special considerations for design and construction of greenhouses that you tell your customers about? I know you're in the controls business, but is there any emphasis that you focus on with them?
What what we generally try and do start is with the crop. Let's say that drives the type of greenhouse, and depending on the crop, if it's medium tech or low tech or high tech, and also for sure adding the location, crop and location, and a little bit also what Brian mentioned, labor, depending on what availability of labor, you're going to have a certain cultivation technique, and for that cultivation technique and for that cultivation tools, one type of greenhouse could be better than other. So it's adding all those variables together to make, let's say, see the options. There's always a couple of options out there, and that give you different possibilities as per investment and also yield, kilos or units, whatever crop you're going to grow. And I would say that all the points we have been talking from the start of this session have to be taken in consideration. That's, let's say, it's not unfortunately it's not it is quite simple because it relates to plants in the sense that that's what we're going to grow, but building a project, designing a project, call it a greenhouse or even an indoor, that's going to you have to take into account all the variables we've been talking about since we started this session.
Great. Holden, tell me a little bit about, you don't have to use this slide as a reference, but tell us a bit about the different kinds of greenhouses, just briefly, different levels of technology, and what other special considerations that you have for when you're designing.
Yeah. So I think, like Luis said, it really starts with what crop are you growing? The optimum greenhouse is also going to be different depending on where you're building it. You could be growing the same crop in, like I said earlier, in Denver versus Chicago, and you're going to get a different optimum solution. I think some of the key differences is, if you're growing in a cannabis facility, light deprivation is obviously much more critical than if you're growing leafy greens, for example. And it can be challenging with all the different pieces and components to get that full light deprivation within a greenhouse. You need to think about all of, for example, if you are introducing a fire sprinkler system, how are you going to penetrate up into that canopy and not get any light leakage around those pipes? And from the construction standpoint, we look at that curtain, and there is a lot of detailing that goes around that curtain to ensure that there is no light penetration through there. And then in terms of like fully sealed greenhouses versus ventilated, odor can be a big thing. If you're in a more populated area and you're trying to grow a cannabis plant, it is difficult to control odors in a ventilated greenhouse. There are systems out there that can help with this, but it's certainly a consideration if you have neighbors that are close by that may complain. And then another big difference, I think, is your HVAC system, and whether you're going to have something like a pad wall or whether you're going to have a fully enclosed greenhouse with like a 4-pipe system, because that's going to change your not only your upfront capital costs, your operating costs, as well as your utility requirements for that particular greenhouse.
Yeah. And I would just point out to our audience that I'm old enough to be able to say that air-conditioned greenhouses really weren't a thing until recently. 20 years ago, you only had them at the big Monsanto's research place, Dow Sciences research place. Maybe a couple of universities would have one little room, but they were just so expensive. They just weren't around. You didn't see them. And so cannabis is one of those crops that has now changed that. And so it's going to make it more feasible. You can afford it theoretically. And so all this new technology is coming on board to help learn how to do air-conditioned greenhouses. But I just want you to know that this is kind of new stuff. So when you get into, if you decide to build a sealed greenhouse, you need to shop very carefully for your builder and designer, and you need to do some good research on this, because it's not It's not cookie cutter. I'll jump to the next slide. We're just talking about greenhouse coverings. I'm not going to go into all of these, but I just want to show you that there in our best practices guide, this is where this chart comes from. It tells you about the U factor, their R value, the light transmission of these different kinds of coverings, the useful life. And that red box that I put down there, I made that last night to point out that the Title 24 regs for California, I believe would keep you from being able to use single wall acrylic. You can use double wall, single pane glass you couldn't use, but you could use double pane and just a single wall of polyethylene and polycarbonate as well. So pay attention to that if you're in California. And we talked about shade curtains briefly. I'm just going to do a quick rundown of this, and we could do a whole session on this, and you can find more information in our best practices guide. But if you haven't thought about them before, there are shade curtains for helping cool and keep the plants from overheating. There's thermal curtains that will help you retain heat at night. There are blackout curtains or light depth that changes the light period, so you can force plants to flower or not to flower if they respond to the light period. And then there are combinations of both shade and thermal weave curtains. So it's pretty complex, right? And you might have multiple layers in the same greenhouse. If it's a curtain that, and I should also point out that you really want them to be motorized as well and responding to your environmental control system. That's by integrating all of this, that's when you really get the power of CEA. If you're going to do energy retention curtains, those have a closed weave, and where other shade curtains sometimes have an open weave that air can, of course, rise up through. And if you do the energy retention, it may take a little bit extra curtain trim around the perimeter to make sure you're getting a good seal. There are special fans for exchanging air above and below those curtains. And we've talked about the challenges of that Holden was mentioning about making sure you're getting a good seal of your curtains around any pipes like that, but there's fans that have been designed to be able to do that above and below. And also from my own experience, I've done everything wrong with curtains. I'm the person to come to if you've got any problems with your curtains. If they are installed without enough sag, that's a problem because they'll rip early. If they vibrate because you've got a fan blowing on them, they'll vibrate along the wires and they will also deteriorate quickly. If you use what's called bakeouts, high temperature regimes to disinfect your greenhouse, yeah, you're going to shorten the life of your curtains. So obviously I've done it all wrong. So come to me if you have any questions about that. Let's jump to make sure I get through one or two more topics before we open up for questions. Let's see, we've got 11 minutes, so we'll just talk about benchmarking design, benchmarking and design in construction system KPIs real briefly. This is a graph from our Power Score software. So if you're a member of RII, you can enter your data and it tells you your KPIs. You compare yourself to other folks with the same kind of facility as you or in the same region. And we give you information, KPIs on efficiency, which would be kilo-BTUs per square foot of canopy, and for productivity, kilo-BTUs per pound of harvest, as well as in the annual facility energy use, the big picture of how many kilowatts hours per day that you're using. Operations and maintenance. I think we've covered a lot of this. I really want to make sure that I'm leaving time for any questions you might have. So I'm going to talk about the statewide CETA programming, and then we're going to jump to the questions. All right. So the California Energy Design Assistance Program is for new construction. The participants receive complimentary services for a whole building energy analysis, assistance identifying and evaluating energy saving measures, analysis of energy costs and paybacks, incentives for new construction and major renovation projects, And also mixed fuels for customers who want the option of both gas and electricity. An all-electric program that option that offers a higher incentives if customers do not install gas service. Okay, so contact the website that Carmen has put on this slide for us, the californiaeda.com. To participate in this also, just like the same moral to the story you've heard so many times, get them involved early, all right? Whether or not you're doing a traditional design or design and build, these green area when you're doing the preliminary design and cost estimates and schematics, and that's when you want to bring in the CETA program. It really doesn't do any good to wait to construction starting or you've already purchased your equipment. And again, our sponsor, Southern California Edison, we thank them so much for this program that we're doing. You can get services from them for on-bill financing, Go Green Business Energy financing, vendor partner rebates and incentives, and summer reliability program, and with links there again. And you'll have access to this deck after the webinar is over, and you can click on any of these to find out more. Okay, I'm going to open it up now. I don't see any questions. Let me see. I'm looking to see if we have any questions in the chat. Anyone in the audience want to ask a question? You can either speak up or you can write it in the chat or raise your hand. While we're waiting, let's talk about operations and maintenance then. Does this is near and dear to me, to my heart, having been a facility operator for so many years, that the maintenance of your equipment is really key to saving for resource efficiency. When you need to be able to clean the glass, for example, in a greenhouse. And if you've got lights, whether or not you're indoor farm or greenhouse that have any sort of glass barrier on them, like high pressure sodium do, you need to clean those barriers. Your old rule of thumb, which has been proved scientifically to be correct, is that for every 1% increase in light, you can get a 1% increase in yield. And that's true across many crops, vegetables, flowers, and cannabis, okay? So although it takes a lot of time cleaning the glass, cleaning your lights, I would also point out having a maintenance program ongoing for your equipment, even if you need to hire that out, to have someone else who'll come in and have a service agreement to work on your HVAC and changing belts and fans if you're in a greenhouse. Definitely monitoring cooling, evaporative cooling if you're in a greenhouse. To our panel, is there any maintenance problem that you see over and over again, or have had the biggest problem for growers?
I think one recommendation I would make, just being in the world we are today, is if there are components that may fail, it may make sense to purchase some of those and have them on hand, because you don't know, it might be 8 to 12 weeks before you can get that replacement part. So things that that I see are on the HVAC side is like compressors, for example. Mm-hmm. Having a few spare compressors on hand, so that you can replace those, in the event that there's a failure and you aren't waiting around for 8 to 10 weeks, is always a good idea.
Go ahead, Brian.
Rob, we call that shelf stock, right, Holden? That's shelf stock. If you don't have an extra compressor pump or
pumps too is another big
pumps, fans, belts, filters, HEPA filters, etc. You've got to have those. One of the most precious design items in any horticulture space is storage. Mm-hmm. And right? Storage gets forgotten about when you're on the design table. So, oh, well, where do we keep all this stuff? The corridor, your harvest corridor, is a lousy place to keep it. In the grow room is a lousy place to keep shelf stock. So maintenance, the other piece that comes to mind, so think about it during design. Think about maintenance in the design field, in the design table. The other is the role that that GMP plays. How do you protect against microbial contamination, biological and physical contaminations? And when these crops are in a process that is FDA controlled, there will be inspectors, and those inspectors are going to want to know what your SOPs are and what your SSOPs are. So having a place in which you can educate your staff to understand the standard operating procedures is another forgotten aspect of maintenance, is that you need a place in which you can train your employees to maintain your quality standards.
I think another thing too, and I'm sure Louise can talk about this, is how can your control systems monitor the performance of your equipment and actually detect, hey, this pump, if you're working in a facility and you have 100 pumps, sometimes it's hard to be able to monitor that in person. So I think with technology today, there are ways that you can identify, hey, this compressor is not functioning properly, or this pump seems to be not functioning properly, and report that back and alert that back through the system of controls to, your head of operations, so they can go and check it out and see, if there's an issue. Otherwise, it can sometimes get overlooked for, a couple of days until someone notices it.
Yep.
Luis, can you comment on that?
Yeah, for sure. That's a good point, Holden, because that's when you're operating a system, a control system, you have different type of alarms, and that I would fall in the category of the technical alarms, in the sense that you get different level of alarms. The colors, let's say the yellow ones are the ones that are just to put attention because there's something going to happen, because it's falling within a certain range that it's not normal, let's say, that you have to take care and you have to plan that you're going to do something. The red alarms, unfortunately, are the ones that don't give you time, and those are the ones you want to avoid. And yes, the control system has, if we gather the data and we can, let's say, use that data properly and it's reliable, that's going to be very, very useful. That's going to make your preventive and even predictive maintenance plan work better.
Right, and those, you have to train your employees to go look for problems. The computer may not know that a fan belt has slipped. It may not know that the aspirator fan inside your sensor box has failed, and now that sensor box is beginning to heat up and giving you an inaccurate temperature and humidity reading and VPD calculation. I'd also point out, thank you, Brian, for talking about storage. It's so true. Storage is the first thing to be cut when there's value engineering going on by the ownership. And keeping those spare parts in hand, it's just an old saying in the horticulture and the greenhouse industry, I'm sure it is in other industries as well, that things go wrong on Friday evenings at 5 p.m. or while you're on holiday. So you got to have what you need to fix it right then. And also keep in mind, a lot of our technology is Dutch, and you're not going to find it locally. So you do need to put it in your budget that you're going to have X number of spare parts of these critical components, because you cannot wait around for 8 weeks to have some of these things fixed. Well, with that, again, I'd like to thank Southern California Edison for hosting us. And I want to thank our speakers today, Holden Orler, Brian Anderson, Louis Trujillo, for a great, fascinating, and informative webinar. If the audience has more questions for us, they can write in the chat now or contact us later, and we can reach out to our speakers and follow up with you. But this has been really fun for me. On behalf of Carmen Azzaretti, I'm Rob Eddy with Resource Innovation Institute, and we thank you for attending this workshop.